to unite what has been set aside.
We are TFR. Truth Frequency Radio.
And ladies and gentlemen, welcome to the Saturday edition of the Paranormal Portal. I'm your host, Brent Thomas, and I'm thrilled to have you here with us tonight. Thank you so much for being here, and thank you for being a part of what we're doing here on the Paranormal Portal. And you guys make us awesome. That's all I got to say. But before I go any further, please let me welcome my good friend and co-host, Mr. Don Longbeard.
That would be this guy.
That would be you, sir. How are you doing today, Don?
You know, if I had a little more sleep, I'd be confused.
Aren't you normally confused? I'm just saying. I just put it out there.
Oh, hey, it is what it is. But it's been a good day, so we're all good.
Good. So we made it, ladies and gentlemen. We are here for our Saturday edition, and we're thrilled that you're here with us as well. As it's Saturday night, please know that the call-in lines are open. If you'd like to call and be a part of the show, we welcome your involvement. The call-in number is 213-233-3998. Again, 213-233-3998 or 833-TFR-LIVE. If you're calling from the UK, if you're up this early and want to call, please go ahead and do that. It's 44203-393-2871. Again, 44203-393-2871. So we have had an epic month so far, Don. Wouldn't you agree?
This is our third interview this month already?
Yeah, I know. And it's not just the fact that it's, that we have guests. It's the caliber of guests we're having. I mean, it's just, it's phenomenal. We started out with Deb, of course, and then we had Robin last night. And tonight, ladies and gentlemen, I'm very pleased to announce
the second coming of
the second coming. A wonderful man, somebody I look up to a great deal. He's a fellow co-host on TFR as well on X Squared Radio. He is a scientist, an engineer, a chemist, an entrepreneur. He is a best-selling author on Amazon, has a new book out, The Charm of Favor. It's a story of the Clinton crime syndicate, available on Amazon. And he's just all of these things, and he's also somebody that has a strong belief in the paranormal and has this amazing spiritual grounding to him and a spiritual awareness, which to me is like the full deal. He's the whole package. And ladies and gentlemen, please welcome Mr. Brooks Agnew to the show. Brooks, welcome to the show. Thank you for being here.
Hey, thank you so much, Brent. Good to be here. It's about time we had an interview at a decent hour.
Absolutely. And by that, do you mean really late at night?
Well, yeah, I mean, because we're late night people.
That's true.
None of my friends are up at midnight. So it's midnight where I'm at in Central Time. So it's just good to have friends that like to talk about this kind of stuff at this time of night. I love it.
It sets the tone for sure. I mean, the late night hours and the paranormal just seem to go hand in hand. I think.
Absolutely. And by the way, I think it's an oxymoron to stay spiritually grounded. I think they're kind of two different things. But
you're probably right.
That's okay. I don't mind being grounded in the clouds.
As long as you say oxy before it, that's fine. I'll take it.
That's pretty good.
Oh, thank you.
I'm stealing that.
Well, last time you were on the show, of course, we had just an amazing discussion, and I can pretty unequivocally say for Don and myself that you absolutely blew our socks off.
Yeah.
We knew you were an intelligent guy, but the things you brought to the table, I mean, clearly you had us sitting here basically drooling wide-eyed and mouth open.
No pressure, no pressure.
Well, the cool part about it was, though, and ladies and gentlemen, if you get a chance, please stop to youtube.com/paranormal portal, and you can check out Brooks's first visit on the portal. And it was amazing. It was, I don't know, a few months ago now. But the nice thing about it was you brought in all these profoundly elaborate and complex scientific principle, but you broke it down in such a way that it wasn't overwhelming. It was digestible even by someone like me, which is which is no easy feat, let me tell you. So you have a bard's tongue as far as
let's see if we can do that again.
Absolutely.
Where would you like to go?
Well, I know one of the things that I'd really like to take more time and discuss tonight, if we could, and it's something that we only got an opportunity to brush the tip of last time you were on, and that was the whole hollow earth idea. I know there's a lot of people out there that believe in this, and then there's a lot of people that don't. And you were bringing some pretty amazing things to the table, but then you just ran out of time.
It happens, doesn't it? So let's see. There's we often use the term hollow earth theory, but it really isn't a theory. It's more of a hollow earth hypothesis.
Okay.
Because normally what we do in science, we find things that we don't understand, and we make a hypothesis about what our expectation is about that understanding. And then we either try to prove or disprove that hypothesis. A null hypothesis is you try to say, okay, the Earth is a molten ball floating through space, and we live on the crust of it just by sheer luck. Mm-hmm. And so then what you try to do is come up with enough evidence to prove that is so. And if you can, then hollow earth theory or hollow earth, the idea of a hollow earth doesn't hold merit. And I guess we've been trying to do that for a long, long time. And we have, fortunately, a lot of instrumentation applied to trying to gather enough facts to validate that experiment. We have seismology, we have oceanography, we have space-based science, we have, even the more esoteric, I'll call them, for lack of a better word, sciences. And with all of that, we still can't prove that the Earth is a molten ball floating through space because the data doesn't support it. I mean, we can manipulate it, which they do. If you open up any geology textbook, you'll see their theory of, why the Earth is what I just described based on seismographic information. Mm-hmm. And what they do to make the data fit is they realize that they're getting vibrations. Let's say there's an earthquake, a big earthquake in the South Pacific. Mm-hmm. And on the Pacific Rim. Well, it thumps the Earth, and the vibrations go through the planet, and they're picked up by seismographs or seismology instruments all over the planet. So it's kind of like, a bat will send out sound waves in a cave, mm-hmm. and it'll bounce off things in the air, like mosquitoes, and it can locate it based on that sonic reflection and go pick a mosquito out of mid-flight. Well, we do the same thing with the Earth. These vibrations go through the planet. They bounce off all the structures in the planet, and they arrive at various times based on how fast sound goes through solid or molten matter, according to their calculations. But the issue is that they get a whole set of waves that should not be there if that was the way Earth was made. So they classify in three ways. One is called a pressure wave, a P wave. The other is called a shear wave, an S wave. But the other set are called shadow waves or a shadow zone. These are waves that arrive at seismograms that shouldn't be there. They don't really know why they arrive there, so they kind of call them the shadow zones. And that's the picture that you see. And I've got the graphic in the book, Remembering the Future, and I've got, it on the website and the presentation that I make about hollow Earth hypotheses. And that's what's in the textbook.
Wow.
But if you run the data backwards, that is to say, start at the seismograms and work your way backwards to the earthquake,
Mm-hmm.
you get a totally different picture of the planet. The picture that you get of the planet when you go backwards is about an 800 or 900 mile thick crust, and then the point of contact on the other side. There's no wave that goes through the planet any deeper than about 900 miles. So what you get is this very clear picture of a void inside the planet.
Wow.
And that's just the tip of the iceberg. There's more information that has since been analyzed and validated and repeated that's available in those waves.
Oh my God. So it's essentially could very well be a big chasm in there is what you're saying. It's not, there's no real core. There's no, spinning ball of nickel or whatever in a molten bed. And it's just hollow. Like when we say hollow Earth, it's not like there's a crust, there's a void layer, and then there's a core underneath that. Is that correct? Or
Well, actually, there is data to prove that very thing.
Really?
What the Japanese have been doing, and what Cambridge University has been doing, and what Stanford University is doing, they all have divisions of what are called planetary core tectonics. And what they have been researching are frequencies that they have been getting from the center of the Earth, from the core. And these frequencies are spectrographically analyzed. And it sounds like a complicated word, but let me try to break it down. If you were to have a blindfold on and somebody in the room played an open string on a guitar, you could tell which one was the E string, which one is the A string. You could tell based on your knowledge of the way a guitar sounds, right?
Mm-hmm.
Well, as it turns out, every single bond between carbon and nitrogen and oxygen and hydrogen, every single bond has a specific length based on how big the nucleus is. And how big the nucleus is, of course, has to do with its position in the periodic chart. So if you go down the periodic chart to the nucleus iron, you will see that it has so many protons, so many neutrons, and that means it has so much of a strong force, all those nuclei, all those proton and neutron particles packed together, which means the bond between iron atoms with one another is a specific length. It's a specific guitar string. So that iron puts out a certain frequency, especially when it's in a large population, like a very dense, solid iron crystal weighing, billions of tons.
Wow.
Sitting there in the center of the Earth. It puts out a single, like a spike on the oscilloscope. And we've been able to validate that in several locations around the planet. So what they've been trying to do, because the shift of this frequency is very slight in terms of nanometers, between, say, a lump of iron and an iron crystal. An iron crystal has a certain dense lattice, and it can only exist at a certain temperature. If it's too cool, it can't exist. If it's too hot, it can't exist. It's got to be a certain temperature.
Wow. Okay.
And that temperature is 6,000 degrees Celsius.
Oh, jeez.
So what the Japanese measured the first time that they did this, they speculated based on the vibrations that they're getting up in this frequency that the temperature was 5,000 degrees Celsius. Obviously, that threw a big wrench in the works, and everybody thought, well, it's got to be something other than iron because it can't exist as a crystal at that temperature. But then Cambridge University redid, two women actually, redid the experiment with what's called an anvil press. So what they did is they recreated the pressures on iron crystal in the lab, and then they heated it with a laser to 6,000 degrees C, and the peaks lined up perfectly. So that means that the core is sitting there at 6,000 degrees C, which tells us it is a solid iron crystal at the center of the planet. If that's the case, and I just happened to watch today another NASA piece, which is actually pretty recent, that's done on exoplanets, different super Earths that are out there.
Mm-hmm.
And they're examining the atmosphere of the Earth and the surface of the Earth and, different winds on these planets. Some of them are like, 5 or 6 kilometers a second, which is pretty high and full of iron dust and shards of silica. So you could never survive on there. But the point is that they made a statement in this about how planets form in the first place. And the very best, freshest, most current astrophysics we have is that planets form out of these exploded stars. So a star explodes, it forms a tremendous amount of high order molecules like titanium and silica and oxygen and all these elements that are formed by supernovas.
Mm-hmm.
But then this dust that's left forms a giant accretion disk, like a giant disk of gases and metals and rocks. And over time, what happens is these begin to attract one another, slowly at first, and then faster and faster and faster. So what happens is a star reforms in the middle, or at least enough density for a star. Sometimes they're only the size of Jupiter, and sometimes they're a little larger than that. But then in the rings that are around this, the rings themselves begin to coagulate along a Fibonacci pattern into planets. And as, of course, they collapse, they spin faster and faster and faster. This is a rule we call conservation of momentum.
Mm-hmm.
It's a little bit like an ice skater. She spins, but she really gets going fast when she pulls her arms in.
Right.
So the smaller the diameter she can make, the faster she's going to spin, because she started out with all this energy in her arms, and then she drew it into her core, and she's spinning incredibly fast, so fast sometimes the camera, can't even see it all. Same thing with planets. And then the planet does one of three things. It either spins so fast that it explodes and comes apart again, or it becomes lopsided. Heavy particles gravitate to one side, it becomes lopsided, and it spins a piece of itself off like a water droplet, and it forms a moon. And that moon can, if it's far enough away from the planet, it will revolve on its own axis. If it's really close to the planet, like our Earth is to us, it becomes what we call tidally locked, which means it's the same side faces the planet all the time. If it gets too close, the planet of the larger body, if it encroaches what's called the Roche limit, will actually overcome the gravity of the smaller planet, and it'll come apart. It'll just come apart altogether, and it will then fall into the planet and become part of the planet again.
Wow.
The point is that this is how our best planetary physics believes that planets form. And if this is the case, there's a third condition I mentioned. Planets will expand and cool, and expand and cool, and expand and cool. And of course, as they do it, like the ice skater letting her arms back out, the crust slows down. And as the crust slows down, the core keeps spinning at its original rate, and the two become separated. One spinning just inside of the other
Like
on
a bearing.
exactly the same north and south magnetic lines. This is what creates a magnetosphere. This counter rotation, a fast spinning core, a slow spinning crust, both of them full of charged metal, forms this giant magnetic field around the planet, and now you have conditions that are suitable for an atmosphere and life.
Wow. So in this gap then, this gap inside is that at some fantastic temperature as well? Or would it be presumed that that would be habitable or potentially habitable?
Well, the answer is we don't know.
Okay.
I mean, because we've only drilled in about 9 miles into our crust.
Okay.
So we don't really, I mean, the crust is 900 miles thick. We've only drilled in 9 miles.
Oh.
And as deep as we've gotten, we know that there are areas that are very, very hot. I mean, just look at Hawaii right now. Look at Guatemala.
Sure.
You'll know what I'm talking about.
Right.
But this is the crust. This is not the core coming through the crust. This is the crust, the mantle of the crust, because the mantle is like a big vibrating 900-mile thick soap bubble. It is not stable. It's moving all the time. It's undulating.
Mm-hmm.
It has its own center of gravity in the center of the crust. So there are really two gravitational lines in our planet. One is the tremendous amount of mass that's gathered in the crust of the Earth, and the other is the core, which is 1,000 miles away from the crust.
Wow.
So if you have a gap there, and it's 1,000 miles thick, and it's full of gas, let's assume it's some kind of atmosphere, then the core would be insulated from the crust. I would imagine it would still be quite hot, but mortals, humans, can take temperatures, as long as they're dry, up to about 250 degrees.
Really?
But we can't take much over that. If it's moist air, we can only take up to about 115, 120 degrees, and then we start to wilt. Because the way our cooling system works, we have an evaporation model. At least I do. And what happens is we push water through the pores of our skin, which evaporates.
Mm-hmm.
And in that evaporation, it cools the skin. So then the skin becomes flush with, small capillaries filled with warm blood. That blood is cooled and then run back into the body. And that's how we maintain our temperature. But that doesn't work so well in a steam room.
Right.
It works okay in a sauna.
Okay.
A sauna is between 225 and 255 degrees, and the human can take that for upwards of an hour, pretty well.
Wow.
Now, I've been reading that they've been looking to drill into the mantle lately.
Yeah, well, you have to get pretty close to the mantle, or the mantle would have to be pretty close to the surface.
Right. They're talking about
for them
finding,
to do that.
like Marianas Trench kind of thing, and getting as deep water as they can to reduce that. What is your ideas on that?
Well, the issues are deep water drilling is hazardous.
Mm-hmm.
We do it in the Gulf. The Gulf is about 5,500 feet deep. We do it in the Arctic, where the ocean is upwards of 4,000 meters deep. But the trench is 23,000 feet deep. It's way down there.
Wow.
The problem is that when you get down that low, you run into other liquids
Right.
that are more dense than water, like, let's say, liquid methane, that sit down on the bottom of these very deep areas in
That's
liquid
kind of dangerous.
because it's under so much pressure.
Right.
Yeah. Well, the Japanese do tap into that methane. They have pipes that go down there, tap into the methane. They pump it to the surface, and they harvest it. They use it for energy.
Mm-hmm.
And that's why oceanic warming can be so hazardous, because if it gets to the point where the methane begins to boil, then it will become gaseous, come to the surface, and mix with our atmosphere, and then we do have a real problem.
Yeah.
Talk about global warming. You know, we have mass heart attacks everywhere, even in low concentrations. Methane, you know, can stop your heart. So we try not to do that. I mean, just raw methane is okay. I mean, we find that in the oil fields all the time. But when it's mixed with other things like sulfur or alcohol, methanol can be very hazardous. It's totally miscible in blood, and it will stop your heart. And certain concentrations, it will give you a heart attack.
So I guess drilling into the mantle wouldn't be very feasible without some serious safety oversights. I mean, like planetary safety oversights.
Right.
That's crazy.
You would have to do it. I would imagine you would not be able to do that from the surface.
Okay, yeah.
You'd have to do it from the bottom.
Okay,
and believe it or not, there's a lot of heavy equipment companies that have manufactured equipment right now, and it is being used for seabed cultivation.
Wow.
They look just like surface equipment, except it drives around on the bottom of the sea, and it harvests metals that are plentiful on the sea bottom. Iron and titanium and all kinds of stuff like that. And it's turning into a very, very big industry.
Wow.
Okay, well, we're going to head to our first break already. It's going so quickly, but ladies and gentlemen, don't go away, and we'll continue this discussion. It's just, as you can see,
it's already baking beans.
It's absolutely amazing. So don't go away, everybody. We'll be right back with more of Brooks Agnew here on the Portal. Stand by. We'll be right back. And welcome back, ladies and gentlemen, to the Paranormal Portal. I'm your host, Brent Thomas, and we are burning this Saturday evening away. We hope you're having a wonderful night. I know I'm having an incredible night. I have a little bit of a headache already, but it's because I'm cooking up a fresh batch of bacon between my ears. But it's one of those things that, of course, our guest tonight is Mr. Brooks Agnew, and he's already hitting the ground running with this amazing knowledge and understanding of the physical world around us, and we're tying this all into the hollow earth ideas and theories and such. But as you're talking, Brooks, I keep thinking, I want to get as much out of you as I can about so many different things, because it's not often you have the option to talk with a person with such a profound understanding about these kind of topics. And I realize we're on the same network and stuff, but you're an incredibly busy man, and when you're talking, I just think, oh, I wonder what he thinks about this. I wonder what he thinks about this. I wonder what he thinks about this. And I just find myself just wanting to leapfrog all over the place and just to hear what you have to say.
Right.
So,
yeah, definitely.
It's your program. Leap away.
Well, but at the same time, I love what you're talking about too. But I'm thinking about things like anti-gravity, about free energy, about the physics of spiritual body, and as we're talking, I'm thinking of the children of Woolpit, the story from England of those green children that came out of what appeared to be some tunnel. And they talked about their land being, subterranean and green, and, there was no sunlight. It was green, and they had green skin. And, I have all these things jumping through my mind when we're talking about Hollow Earth. But I do want to ask you, because this is something I'm curious about, when we're talking about the idea of the Earth being a crust with a mantle, and then some kind of space or void, and then a core, does the dynamic of gravity change when you move closer to that dense core? I don't understand gravity well enough to know, but as you go inward, does the power of gravity change, or is it consistent throughout?
We believe that gravity does change. If you read Newton's musings about gravity inside of spheres, he has what he calls a section called thin shell physics. And in thin shell physics, it's of course largely theoretical and mathematical. And what he basically says is once you're inside the sphere, all the gravity cancels itself out and you're weightless.
Oh.
And theoretically, that is correct. But then he has a section that he calls thick shell physics, which is, if you just look at the math formulas, it's an extrapolation of multiple thin shell physics. So the answer is we don't really know for sure, because we've never sent a probe inside the planet, so we have not measured it to be sure. But what we can do is a thought experiment. So if, for instance, I were to take everybody listening tonight, all million of us, and put us into an elevator at the surface. And then we're going to take the elevator to the core. And we're going to be standing on a bathroom scale in the elevator. So as the elevator goes down deeper and deeper, 1 mile, 100 miles, 500 miles, 2,000 miles, what do you think our weight is doing on the bathroom scale?
Well, to be honest with you, I'm thinking that the way the scale measures weight might change because the density of it would change if gravity's different. Is that right or no?
No, let's just assume, let's cancel all that out.
Okay.
Let's just say what we're talking about is you and I, we are currently accelerating toward the center of the Earth at 32 feet per second. Fortunately, we're standing on the ground, so our acceleration is arrested by the ground. But we're still accelerating toward the center of the Earth at 32 feet per second, and that's why I weigh 0.1 metric tons. on the scale when I'm here on the surface.
Okay.
But the truth is, as we get closer and closer to the core, the very mass that's creating that acceleration is getting smaller and smaller and smaller. Oh. In fact, at a certain point, you can say there's more mass above my head than there is below my feet.
Oh, sure. Okay.
So there is a point at which, and this is actually measurable, because we've measured gravity on the top of mountains, and we've measured gravity in the bottom of the valleys, and we find that there is a difference.
That's right.
Oh.
In fact, theoretically, your head weighs less than your feet.
That's right.
Just in that short, theoretically. It's probably not measurable because we don't have that resolution, but we can tell, say, from the top of Everest to the bottom of, say, Holland, or some of the low places in the Earth that are below sea level, we can tell the difference. It's measurable.
Okay.
So if it's measurable in 8,444 meters, which is the height of Mount Everest, then it should be measurable in 8,444 miles, which that puts you on the other side of the planet. But somewhere in the middle, you would reach zero gravity.
Oh, okay.
So if that's the case, then that means that the crust that is now above your head, because let's say you're 2,000 miles into the planet,
Right.
the crust is actually attracting mass upward.
Ah, so it is
So the
pulling
crust-
upward. Oh.
Yes. You could actually stand on the inside of the crust the same as you can stand in China on the other side of the planet and still have my feet are facing the feet of people in Beijing right now.
And that is exactly where we were going with that, because now that speaks to something possibly living not on top of the core like you would think, but actually on the bottom side of the crust or the mantle. And that brings to question the sun in the center of the Earth. You see where I'm going with that?
Yeah, but let me add a little bit more credulity to the possibility.
Okay.
Because there was an experiment done. Now, it was with data that was already collected. It was collected for a long time without this idea in mind. But the data was later treated by graduate students at Washington University under the direction of Dr. Y. Sessions. I brought this up in the last time I was on your program.
Mm-hmm.
They took 600,000 printouts, the seismograms themselves, and they analyzed the wave shapes of those seismograms, the vibrations that are picked up by these seismometers, which, most of the vibrations, the big vibrations, do come from earthquakes, sometimes more than, 1,200 earthquakes in a day.
Right.
They're small, one or less on the Richter scale. But there are other vibrations that are picked up. And it's these other vibrations that really made a breakthrough in the idea that planets might form as hollow spheres. Because what they picked up in the vibrations were actually damping waves of water crashing against a shoreline underneath the crust.
Right.
Wow.
In fact, this ocean that they measured was larger or about the same size as the Atlantic Ocean, and it was underneath the Atlantic Ocean.
Oh.
Wow.
So if you have waves crashing, that means that you have airspace above the water, for one thing.
It has to.
You also have gravity. You also have gravity holding that water against the bottom of the crust.
Huh.
Now,
That's incredible.
I'm not a paleobiologist,
That's incredible.
but I will tell you, without any doubt in my mind, that if there's water there and there's airspace there,
there's life.
liquid water, I guarantee you there will be life.
Sure. Now, is there a possibility that those bodies of water could somehow be connected from the surface to the under surface?
Well, that's what we wanted to do with the North Pole in Earth expedition. What we wanted to do was rent the icebreaker for 15 days, and we wanted to go searching for that vent. We were running on the assumption that there's no big, 150-mile wide or 400-mile wide whirlpool that is in the ocean that leads down into the center of the Earth. We were saying, okay, let's say that doesn't exist.
Right.
Because I think that would have been spotted by now. Let's just say 4,400 meters deep, there's a huge fissure in the ground, and the two oceans are mixing at this point. Now, hear me out, because in 2007 there was a really anomalous temperature and wind condition in the Arctic. It was warmer than usual, it was windier longer than usual, and what happened was the polar ice cap calved. That is to say, it broke off a state-sized piece of ice.
Oh, sure.
And the Northwest Passage became navigable for the first time in, well, I don't know, maybe 100,000 years. I don't know, a long time. The interesting thing is that in the year 2008 and 2009, they were doing marine sampling off the coast of Malaysia. They do this ever so often, and they sample specific species of rays, like manta rays and stingrays, rays, because rays, as it turns out in the ocean, are very sensitive to ecological changes, chemistry, temperature, CO2 levels in the water. They're sensitive to it, and so they sample those life forms and, do measurements on them. Normally, they find between 20 and maybe on a high end 50 new species of rays because they mutate rather quickly.
Right.
In 2008 and 2009, they found 1,500 new species of rays.
Wow.
Oh, my God.
Now, when you couple this with the fact that the Northwest Passage became navigable, that somehow this fissure might have become exposed to our ocean, it's possible that the two ecosystems mixed.
Right.
And some of the species that only exist in that realm were drawn up through that fissure and made their way to warmer waters.
Oh.
I say that because there were things about these rays and other species of squid and things like this and sharks that we thought were extinct for millions of years.
Right.
We found fossils. But these were not fossils. These were fully developed adults. These were healthy, swimming animals that we have not seen in nets ever. We found, as I said, fossils, but nothing alive. Things like a dorsal fin squid, what's called a frilled shark. It has no eyes. It's made to swim in waters that don't have sunlight. It navigates other ways.
Wow.
And all these species sprang up in like this period right after the Northwest Passage opened up. That's why we wanted to go up there and find this fissure, because we thought if we could take water samples as close as we could get to it, and we would be able to prove that the water chemistry was different, the crystallinity of the water, that is to say when it freezes, the salinity, the acidity of the water, and maybe even microbial life, plankton and other things that would exist inside the earth probably wouldn't survive on the surface of the earth because of the exposure to sunlight, but because it's a different wavelength altogether. We're talking, from about 300 nanometers all the way to about 1,100 nanometers from the sun, but you're not going to get that broad range of frequencies from an iron crystal.
Right. Wow. So do you believe then that the iron crystal actually is potentially illuminating this interior if it's there?
Oh, there's no doubt. At 6,000 degrees C, iron will put out a white light that is suitable for photosynthesis.
Yeah, there you
That's
go.
outstanding. You heard it here, ladies and gentlemen.
Awesome.
That is so cool. And this is why we say it's the science of the paranormal, because of course the idea of a hollow earth is in mainstream science, anything that doesn't follow the what I want to say, the propaganda that is accepted, then it becomes a joke. It becomes a mockery. But when you're hearing things like this, it suddenly creates a whole new level of plausibility to these beliefs and these accounts that people claim to have, and I think that's incredibly profound.
And what's nice about it is this is science that's talking and extrapolation from that science.
Right.
If you want to be hard-headed about, there's no such thing as evolution and science is a joke and it's all, religion, or if you're on the other side of that, if you're all science, then there is no doubt that you have to believe this. This is my
But,
my
but wait a
opinion.
minute. Wait a minute. I am hard-nosed. I don't believe in evolution. In fact, I don't think there's such a thing as a theory of evolution because, as I said, theories require facts.
Right.
And they don't have any facts to back up evolution.
Oh, fantastic. Okay. Well, that's good to hear because, again, that's another thing that's just jammed down our throats and we're just supposed to accept it.
Absolutely.
Yeah.
Absolutely.
What is the game plan with that anyway, Brooks? Being a scientific insider, what is the game plan to them, jamming these rationales down people's throats and mocking anything that disagrees with it? What are they going for?
Well, one might think that this is a battle of ideas and that some idea is going to win. Let me lay that theory to rest right now.
Okay.
That is not the plan at all.
Mm-hmm.
The plan is to keep the system in a state of confusion. If I were, let's say I were a Nephilim, I was tasked with watching over mankind, and I screwed up and, screwed the pooch, so to speak, and I lost my authority to do what I was supposed to do, but now I'm cursed for being here. So I'm cursed to being here. What I would do is I would form as many religions as I possibly could, and then I would immediately assign all these religions to hating all other religions. It would be beautiful. It would be a magnificent maelstrom of chaos. And then just to make things interesting, I would throw in the theory of evolution just to make the scientists believe that all the religions are wrong.
It reminds me of that Far Side comic where God's making the earth and he said, this ought to make it interesting. And he's got a shaker full of jerks. He's tapping it out over the bowl.
That's about right. So that's about it. I mean, there is no theory of evolution. There's a hypothesis of evolution.
Okay.
But for all the experiments that we have done, and believe me, there have been millions of them done, fruit flies, bacteria, horses, dogs, everything you could think of, and not one single solitary example of one species jumping to another.
Wow.
There are no missing links, no fossils of missing links, no DNA of missing links. It doesn't exist.
Wow.
Wow.
So let's take this hollow earth.
There's that.
Oh, go ahead. I'm sorry.
Well, I was going to say there's adaptation within a species
Okay.
because genes are remarkable proteins. They actually have a range of proteins that they can replicate, and depending on stresses that are put on the environment, and they could be all kinds of things from temperature, exposure to sunlight, diet, predators, infections, all kinds of stuff. Genes will make a variety of proteins, but they don't jump species. That doesn't happen.
Wow. Okay. So, wow. I mean, that's a whole nother journey altogether. You have to come back more and more. It just spider webs every time. It's like, I want to ask him this, but I want to ask him this, but I want to know what he's going to say about that. I keep doing this in my head, but I was going to say back to the hollow earth idea. Then, have you heard the story of the children of Woolpit?
I've heard various stories, and I, as a scientist, we're not supposed to throw out any data. Although I must confess, there are people, even in my science, that do it all the time. They throw out data that doesn't agree with their hypothesis, and that's just wrong. Because you could fool people for a long time doing that, but eventually somebody's going to say, what about this? For instance, his name escapes me right now, but he's the author of a book called Biological Predestination. Mm-hmm. It was a textbook in molecular biology, and believe it or not, it was a bestseller, which is really odd for a textbook, for a deep textbook.
Wow!
And it was because of this popularity and because of his incredible leadership in this science, that he attracted very, very brilliant students. And one of the students one day asked him a question that he could not answer, not for a little while. They said, look, we understand the complexity of these macromolecules unfolding and then refolding back up, duplicating themselves through the chromosomal activities of nuclei of various cells. But where did the first protein come from?
Mm-hmm.
And that he could not answer. So about the end of the semester, he came back and he said, look, I want to answer your question about where did the first protein come from? Where did the first DNA molecule come from? And he said, plain and simple, it's an engineered molecule.
Oh.
Wow.
Oh, no.
Okay.
Wow.
So now we're talking about intelligent design. We're talking about intelligent energy and intention put into the building of a molecular system. And make no mistake, DNA, it's a brilliant, helical molecule, but it is a system in and of itself. It isn't alive, but it has a program written into it with amino acids. And each genetic makeup has within the limits of that program certain things it can do, which is remarkable and very broad, very adaptable, and certain limits to what it cannot do. And that's why, we have species go extinct all the time, because they cannot any longer adapt to the environment. They've run out of choices in their proteins, and they can no longer survive.
Okay. So it's just a matter of the certain. It can sustain certain stressors for a certain period of time, or a certain introduction of stressors up to a point, but at some point it's just going to collapse.
It either adapts or collapses.
And I would add something to that, because it has something. Well, it has a lot to do with the level of consciousness of the being that's occupying that biological transducer. I say that with confidence because, when you're talking about one-celled animals being able to add, highly complex machines like a flagellum or an eye or something like that, and be able to, vastly improve their survivability. Mm-hmm. That doesn't happen through mutation. That happens with intelligent design. But humans are a little bit different. We have the ability to behold, and that's a very powerful word of observation these days. Mm-hmm. We have the ability to behold our environment, not just the environment we're sitting in, but the past environment and the future environment. Uh-huh. And when we apply our attention to those things, we are, by definition, putting energy into those realms. And that will change those realms. Like the movie Next, when Nicolas Cage in the very beginning of the movie is narrating it, he said the future changes because you looked at it. Mm-hmm. Uh-huh. That is true. So humans are much better and much more powerful at changing and altering our own choices that our genes can make. We've seen it too many times in medical history and recent medical history. People that pray tumors away. They don't take any drugs. It's just their intention or the intention of someone else applied to that biochemical structure changes that biochemical structure, and the cancer ceases to live. It dies. It goes away.
Wow. That is absolutely amazing. And it's again, the whole idea that by observing we change the matter, but what you're saying, we actually change the future. And what about the past then? Is that also changeable?
Within a range, yes. Okay. In my book, Remembering the Future, I assert that time is not a straight line behind us. It's more like a drinking straw or a funnel, the small end of a funnel. There are ranges of changes that we can make to our past. Yes, you can go back and you can change the past. Now, you can't replace that finger that you cut off when you were 17 years old, or the eye you poked out, or thumb you lost on the wringer washer when you were 5 years old. But you can change how you react to it, and that can change everything.
That's profound. We're going to go to our hour break, ladies and gentlemen. Again, our guest tonight is Mr. Brooks Agnew, and it's nothing short of amazing, but we'll continue the discussion on the other side of the break, so don't go away. It's only going to get better, ladies and gentlemen.
Truth Frequency Radio is your number one source for news and...
Play their games. Everybody loves to place their bets. They don't understand the price I paid. They don't care to comprehend. Trace their lines upon my body, ripping scars across my heart. Raging anger boils inside me as their lies keep falling apart. With my silence, I am not a stupid boy. No more breaking me with kindness, just you dance upon my joy. Leading me with empty promise, you're just another fucking mess. Taking off the slice of my sanity, just make sure that you're well fed.
This looks extraordinarily bad.
They linger in a perpetual dream state, a nightmare from which they cannot wake. I can't see you, Mommy. Where are you? I've never sensed anything like it. Carol Ann is not like those she's with. they're attracted to the one thing about her that is different from themselves. Her life force. It is very strong. It gives off its own illumination. It is a light that implies life and memory of love and home and earthly pleasures. Something they desperately desire, but can't have anymore. Right now, she's the closest thing to that.
Poltergeists are usually associated with an individual. Hauntings seem to be connected with an area. A house, usually.
Poltergeist disturbances are fairly short duration, perhaps a couple of months. Hauntings can go on for years.
Welcome back, ladies and gentlemen, to the second hour of our show tonight. This is the Paranormal Portal. I am your host, Brent Thomas, and we are burning this Saturday away with nothing short of magnificent revelation and possibility into the paranormal realms and reality as we know it, or thought we knew it, and now realize we didn't know it at all.
Don't know nothing.
Then we realized how dumb we are. Thank you, Brooks. But please welcome Mr. Brooks Agnew back to the show. Welcome back, sir, and thank you so much for being here and being a part of our journey and bringing such a phenomenal depth and understanding to the program. It's just, I mean, it's just, I don't know. You've totally. I don't know the words to describe what you've done, but
well, he's made me happy.
You gave Don a huge smile because, I mean, it's so profound to hear. Not only is there a probability that the Earth is hollow, but that there's a possibility there could be life in there. And by not hollow, I don't mean to say hollow, but there's a possibility of another biosphere existing with underneath our feet that could support life on its own, independent of us, and perhaps, intermingling with us.
Or choosing their absence from us.
Yeah, well. Can't say I blame them for that. Not like we've got it all together up here on the crust. But
I like the way you say possibilities. That's what we're all about.
Right.
My colleagues and I, we talk about this stuff until we run out of air, and we're always talking about the possibilities. One of my good friends lectured for a long time, wrote some amazing books. His name was Amit Goswami. He's a lecturer. He's a professor for a long, long time. And he always talks about the possibilities. He really taught me to enjoy that word.
Mm-hmm. Yeah, well, I mean, clearly, I think one of the beautiful things about this is that, and this is something that I would have expected, is that having the kind of grounding that you do within the scientific principle and understanding that in a lot of cases it seems to be at odds with a spiritual reality. But I think that, as we move forward, there's not so much, a this or that principle, that more people are maybe becoming a little more holistic about understanding and finding understanding in, through science to complement their spiritual realities, I guess is the best way I can.
I hope so. I know the secret to life is clean glassware and conversion factors. If I could just get people to understand that, we'd have world peace. I just know it.
That's what's in my bottle. I understand that. Sugar is a wonderful thing.
So, I would like to take a few minutes, and since, again, it's one of those things where I want to cover as much ground as we possibly can with you. But, what do you think about the whole concept? And this comes up a lot in the disclosure movement as one of the benefits of the disclosure movement, they believe, would be the opening up of these ideas for free energy, or having, the ability to generate energy at any place. And a lot of these ideas seem to center around tapping into the magnetosphere of the Earth and being able to resonate with that and create energy. Is there any, as you understand it, are any of these principles or theories sound, or is it a lot of smoke and mirrors? What's going on there?
Well, I mean, yeah, of course there's smoke and mirrors, but it depends on what you're talking about. When we tend to think in our society about energy, we tend to think about the power lines and the transformers, and we spin up generators to make 161,000 volts. We put it out on aluminum lines that goes out to substations. It's stepped down through a series of transformers, divided and divided and divided, which increases the current and allows us to spread it out to a whole bunch of houses in parallel. And that's the way we think about energy.
Mm-hmm.
And in speaking at several breakthrough energy conferences around the world, I have said, the guy that brought us here, Nikola Tesla, he introduced a principle that the powers that be, the masters of the universe, so to speak, have ignored since day one. You guys all want to do three-phase, high voltage. You want to tie it together in a grid from California to New York so that you can, move energy around like water in pipes, and you want to meter it and sell it. And not only that, you force society to live along your wires.
Mm-hmm.
So if I look at the United States from space, I can see the wires from space. I can see where people congregate based on the way you distribute this energy.
Sure.
And that distribution has created a lot of problems because mankind was not meant to live in groups of 3 million people. We're meant to be agrarian. We're meant to spread out in small communities. We're meant to decentralize, not centralize. So that's the way we try to approach energy. We went back to the basics and said, look, why don't we rediscuss low voltage, local supply?
Sure.
How about no more power lines, no more nuclear power plants, no more hydroelectric dams, no more coal-fired plants spinning up, 20-foot diameter generators to make electricity? Why don't we generate the electricity at the other end, like at the house or at the hospital, or the police station, or the individual traffic light?
Mm-hmm.
We don't need to connect anything, nothing,
to
make a traffic light turn on. All you really need are two dissimilar magnets and a copper plate to make the gas inside of a light, the electrons around the gas inside a light, to phosphoresce, to fluoresce.
Yeah.
You don't need any electricity at all. You could just make the magnetic field make the gas inside these lights fluoresce. It'll put off light, no electricity up to it at all, and it will do it virtually forever until the gas changes state inside the tube.
There you go.
So all you need is a traffic light that moves the magnet back and forth to turn the light on or off, or a shutter over the light. Just let the light burn all the time and just shutter the light, or put a liquid crystal in front of it to turn it on and off. Something that runs on almost no energy at all, maybe 6 volts or 4 volts.
Mm-hmm.
You see, this is the kind of technology that's out there, but it isn't used because it's not connected to that grid.
It's not paying the big dividends.
We propose...
It's not paying the big dividends.
Well, of course. I mean, if I showed you a way to light every room in your house, and you don't even have to change light bulbs. You can go to Lowe's and you can buy the regular old little pigtail, the little swirly fluorescent tube that you plug in that now replaces the incandescent bulb.
Mm-hmm.
You could take that bulb, place it in between 2 wire-wound neodymium magnets sticking off the end of ferrous magnets on copper plates, and that light will light. You don't have to plug it into anything. You could light every room in your house virtually forever without using a single milliwatt of energy.
Wow.
That's yeah.
But that's just lighting. So again, you're not going to be able to air condition your house with that kind of energy. You're not going to be able to cook with that energy. You're not going to be able to pump water from 300 feet below the ground up to your water system in your house with that kind of energy. But there are other forms of almost
free energy.
I'm not going to say free energy, but very efficient energy that you can generate using sunlight, using wind, using geothermal, using even the magnetism of the earth. If you have enough area to stretch the wire,
really,
or if you have a moving body of water like a river or wind blowing, you can use the dynamo effect and induce a current flow in the wire that way, up to 200 volts. But again, this is low voltage, local supply, unmetered, which means man could live, the way we were designed to live, in social groups instead of super cities.
Right. Yeah. Yeah. That to me is just profound as hell. And actually, there's a video going around on Facebook that shows the exact experiment you're talking about, of the neodymium magnets being wrapped in wire and then put on two ferrous magnet as well, and then sitting on top of copper
you have to have the dissimilar magnetic fields, or you don't get the movement. You don't create the focused flux lines that excite the gas inside the tube.
Right.
This won't work with LEDs. This won't work with incandescent bulbs, but it will work with mercury vapor, which is what's inside those bulbs.
Right. The fluorescent, fluorescent bulbs,
Yeah, and the guy shows it, and of course, I've seen many of the con videos that are out there on YouTube about the free energy and people mounting little pancake batteries in these, look like bulbs and putting them by these weird wiring contraptions, and then, and of course people are buying it hook, line, and sinker because we want to believe that this is possible. But it's good to hear that that demonstration that I saw on that Facebook video that is valid, because that's exactly what you just described.
You still gotta. You're not talking very much energy. You're talking maybe 20 watts.
Right.
It not even that really, because you're not really exciting the gas with the starter that's in the bulb. You're talking a very, very small amount of power. And of course, I think the light that you see on that video, it's greatly exaggerated by the camera.
Oh, okay.
Because it's not very bright. It's not nearly as bright as that bulb will burn if you plug it in.
Okay.
Because the starter is gonna make that liquid piece of mercury go to gas inside those tubes, and then that's gonna vibrate the electrons somewhere in the neighborhood of 290, maybe 300 nanometers, which you definitely don't want to look at. But what that does is it excites the dope. That's what we call it, dope, on the inside of the glass.
Okay.
And that dope on the inside of the glass is what takes the short UV, the UVC that's inside that bulb. It's what we call germicidal UV. And it makes the dope fluoresce in the visible light range. So it's a much more safe wavelength you could be exposed to for long periods of time without any problem. It's way up close to 400 nanometers, so it's visible white light. It's a broad spectrum of light, depending on what kind of dope is inside the glass. But it's exciting with a mercury vapor on the inside.
So you had also talked about having enough area to run a wire around a property in order to tap into the magnetic field as well. I don't know, is it possible to explain that, or is that something that would be just too intricate to explain how that type of generating would work?
Well, the electromagnetic effect is that when you have a moving magnetic field, you induce a current flow in copper wire or in any kind of metal. So the theory is, with enough rounds of wire and a long enough, basically, antenna, you're going to pick up the magnetic fluctuations in the earth around you, just say 10 acres. If you were to run, I don't know, say a couple of miles or 3 miles of wire around and around and around on poles, you'd pick up those magnetic fluctuations and it would induce a current flow in that wire just through the dynamo effect.
Okay.
I don't know how reliable it would be, but I think the voltage, could be substantial. You'd have to have a way to store it when the magnetic fluctuations are significant, and then use that energy when the magnetic fluctuations are not.
So the Earth's magnetic field is not necessarily constant either. Then it's fluctuating quite a bit. Is what you're explaining?
Yeah.
Okay.
Yeah, it's fluctuating all the time.
What kind of an EMF field would that create within that perimeter of copper wire? Do you think would that be harmful to a person?
Nope, because it's DC.
Yeah, that's right. Yep.
There are certain frequencies that are more harmful than others. In fact, one of the most irritating to the human body is 60 hertz.
Right.
Which is remarkable why we even picked it. The way we've gotten used to 60 hertz, it's fairly easy to generate with a generator. That's why it's that speed or that frequency. But it also happens, if you go way back to the early televisions, they had a phosphorus screen.
Right.
And what would happen is the electron guns would shoot electrons at the screen and make the screen phosphoresce.
Right.
And that's what we see as the picture on the face of the glass. That's why when I was very young, my parents said, don't sit so close to that TV, that electron gun is shooting electrons, which it was. But it had a flyback circuit. And a lot of people don't know this, but old TV tubes used to have a high voltage flyback circuit. It's like a ring around the picture tube.
Right.
So when the electrons would smack into the fluorescing or the phosphorescing screen, and rather than go through the glass, they would get sucked off to the sides in this flyback circuit. And so the damage was minimal, especially if you stayed back about 10 feet away from the TV. But what happened was sometimes the frequency of the electricity would get down to about 40 hertz. And at 40 hertz, your eyes can see the flicker.
Right.
And so they increased it to 50 and then 60. And in fact, when computers first came out, their resolution was much better than a TV because you're sitting a lot closer to it. And so they flashed at 70 hertz so that you wouldn't see the flicker. Your brain wouldn't see the flicker and it wouldn't give you a headache.
Oh, my goodness.
Years ago, many years ago, when I was a line mechanic, I worked for Volkswagen when we had air-cooled engines. And Volkswagen, in their brilliance, I mean sheer brilliance, on the rear of the engine, of the air-cooled engine, when you're tuning the engine, it has a pulley that is the crank pulley. It's right on the end of the crankshaft.
Right.
And it's a folded, a stamped piece of steel that is the pulley. And it has flutes in it, or grooves in the flywheel. Well, there were exact number of flutes in that flywheel, so that if you were using fluorescent lights in your shop and you tuned it to 860 RPM, the flutes would stand still.
Wow.
Yeah.
Because of the 60 cycles from the lights. You were basically using the fluorescent lights as a strobo tack on the engine.
Yeah.
And you could tune it to exactly 850 RPM.
To hell with timing chain timers. You were talking about, going from 40 to 50 to 60 to 70 hertz. And you said that, at 60 hertz, that's where it starts to actually do some damage. Or we start to notice it, shall we say. What kind of... I'm getting conspiratorial here. What kind of... why would they pick 60 hertz? Was that necessary?
Because that's the speed they can spin the generators at. These generators are big. They're huge.
Mm-hmm.
And so you know, they can spin at about, because they're like 24 feet across.
Right.
You can't spin something like that at 1,750 RPM.
Well, that would be true. Right. Because that brings in the question about how could things like that, you talk about the flicker of the old TV sets and things like that. That brings up so many conspiratorial things in my head, you know, from subliminal messaging to, you know, whatever else may be out there. But I digress. I'm so far off base right now.
Oh, it's fine. It's, you know.
Well, the whole reason they went to AC, alternating current, was because of the line loss on the wires. With DC, you'd have to have, you know, amplifiers and consume all kinds of energy in order to run it along transmission lines.
Right.
But that wasn't Tesla's idea. Tesla's idea was to have local receivers pick up the DC out of the air and just use it right there locally.
Right.
It wasn't supposed to transmit along lines, you know, all the way across the city. That wasn't his original design.
He designed
but of course, Westinghouse and Edison couldn't make money that way.
Right.
Right.
Yeah, because he designed it that in each individual family or a compound, for lack of a better word, community, small community, would use its own power. Just like you said, you know, you wouldn't be able to power mega cities with these things. They would be just local.
Right.
Yeah. So yeah.
And remember, it was Tesla came up with AC, but then he later said, no, you don't want to use AC
it's too dangerous
because that's harmful.
Yeah.
And he tried to get them to go back to DC, but it was too late.
Yep. Wow.
It is just amazing, and you know, the ideas are just fantastic though. But the ramifications of these things, even just creating your own free lighting in a house, could shed so much of a power bill for every family over the course of a year.
There would be no power bill.
Well, no, there would be, because you'd still need to run the refrigerator.
Lighting's not much.
Yeah.
Lighting's maybe 1.5 kilowatts for a house.
Right.
It's not much.
Right.
The big energy is used in heating and air conditioning, water heaters, dryers, cooking. That's the thing that uses a lot of energy. Yeah. And, you know, the average house has a 200 amp service.
Right.
It rarely uses 200 amps all at once.
Right.
And sometimes the air conditioning is running, and you're heating water, and you're doing the laundry, and you're cooking, and your refrigerator's on all at the same time. And that's why the service has to be the size that it is.
Sure.
But in the 50s and 60s, houses had 60 amp service.
Wow.
60 amps. That's it.
Huh.
Wow.
Houses didn't have central air. They had swamp coolers. They had fans. But people didn't demand that their houses stay 72 degrees year round. Now we do. It's, you know, we're creatures of comfort, I guess.
Yeah. Well, I am, for sure. I'm pretty guilty of that myself. It's like, oh, I'm sweating, turn on something. But, you know, it's kind of the
I'm kind of partial to wearing less.
Oh, God, you're getting all racy on me here. You might have to go to an unscheduled
if
break.
you go to Arizona, you know, not many people have heat pumps. And if you go to Arizona, most people have swamp coolers. Why?
Yeah.
Well, because the dew point is like 30 degrees. It's amazingly dry. So a swamp cooler is very effective at cooling a house.
What is a swamp cooler?
In Tennessee or Kentucky, a swamp cooler wouldn't work because the dew point is about 55 or sometimes 72 degrees.
What is a swamp cooler? I'm not sure I understand what this means.
It is a box that goes on your roof.
Okay.
And it sprinkles water over the filters, and then it has a fan, and it draws air in through the wet filters. The water evaporates, which cools the air, and then blows that cool air inside the house.
Right.
Oh.
So even though it's 116 degrees outside, it can blow 60-degree air inside and provide moisture.
Oh, cool. Okay. I wasn't familiar with that term at all, but I've never had the luxury of living any place that didn't have winter. So
Yeah, no doubt.
not yet anyway.
Well, They're all over the place in Southern California and Arizona and Nevada. They use swamp coolers
Yeah,
a lot.
wherever it's a dry heat, it's got to be a dry heat.
No, I would think that ideas like that, the magnet setup that we were talking about in terms of illuminating fluorescent bulbs. You know, I saw there's this guy that has this company, and he's basically made this gravity light. It works on, you know, kind of like the old, as far as I understand, it works on the principle like the old grandfather clocks that you know you move up this weight, and over time it pulls down and generates electricity enough to light a bulb at night. Oh, I guess we're going to break. I will bring this back up on the other side, ladies and gentlemen. We'll be back with Brooks and Agnew in the last half hour of the show. Don't go away. This is just nothing short of amazing. We'll talk to you in a minute. Ladies and gentlemen, we are back. This is the last half hour of our show, and it's gone screamingly fast. It always does here on the portal, but having done this for a couple years now, I'm kind of used to the fact that the show just kind of flies by, and I've gotten used to the pace of the show, even though it still sometimes surprises me. But tonight, it absolutely floors me. I mean, we've hit breaks, and I'm like, wait a minute, that can't be right.
Yeah.
So we've got a time paradox going on here tonight, and more so than normal, but it's the quality of the conversation. And, of course, that is thanks to our special guest tonight, Mr. Brooks Agnew. Again, Brooks, you've you've been amazing, and you definitely never disappoint.
Well, I like your idea about. Hold on a second.
Okay.
Housekeeping.
I pulled the headset out of my ear. I like your idea about the potential energy, like the grandfather clock, where you pull the chain and raise the weight, and then over time the weight falls and keeps the mechanism of the clock running, because it doesn't take very much to make the wheel go back and forth, back and forth.
Right.
And I think that's a wonderful idea. We forget when we're talking about free energy or over unity. That's a word I wish I never heard again. Energy can be neither created nor destroyed.
Yeah.
But if there is a way to convince energy to come into our experiment or our house or our thing that we want to light or heat or color or whatever.
Mm-hmm.
And I like the idea, if you really want to talk about minimalism, you really want to talk about using as little generated power that costs money as possible. What about in the old days, in the flats of some of these high-density cities, they used to have coin-operated meters. You could put coins into the meters, and it would give you energy for however much money you put in the wall. And then they would just come around and collect the money. I mean, that wouldn't work today because we're trying to, get away from cash anyway. But it would work with debit cards or something like that, unless somebody didn't have any money, then they'd go cold. But what about wind-up appliances?
Sure. Right.
Like you wind up a big mainspring inside the machine, and believe me, we have some bimetal springs that are incredibly powerful.
Yeah.
And then using the spring energy of that wind-up to run a generator to make the energy that you need to run that particular machine, like toast a couple slices of bread or turn a light on. You just have a little crank and you wind up the mainspring, and then that light will light for 30 minutes or an hour or 2 hours.
Right.
Why not?
Yeah, exactly. And it's these old concepts that have kind of gone the way of the dinosaur, but they're still relevant today, I would think.
We built a house out in the country one time because the country was cheap to live, and we could buy 2 acres of land for $1,000.
Mm-hmm.
But it didn't have electricity out there yet. So what we did, we wired the whole house for 12 volts.
Yeah.
And we ran it on car batteries.
Yeah.
Wow.
Yeah.
Every Monday, we would take the car batteries to the shop
and
charge them all up.
Yep.
Wow.
And it was enough energy, because we had like 20 of them in parallel. It was enough energy to run the lights for a whole week for the house and the radio.
What about the coffee pot?
But the coffee pot ran on a wood stove.
Well, there you go. Well, good thought.
There you go.
I keep thinking of creature comforts. I'm sorry. Cowboy coffee's just fine for damn things.
We didn't have air conditioning.
Right.
Sure.
Right. Wow.
And we burned wood in the wintertime, which a lot of people are like, what? You burned wood, you polluter? Okay, well.
Oh, okay, yeah. So let's talk about your oil heat there, pal.
Yeah, I mean, anywhere you generate electricity, it's using some kind of process that's got waste. So
coal.
We're coming to you from the north of Idaho, where wood burning is still a way of life up here.
I have a wood burning furnace in my house.
Yeah, that's right. Yep. So
I lived in Glen Ferry, so I'm familiar with that.
Yeah, yeah.
Absolutely.
Crazy.
Now, what do you think of things like, just to try to squeeze another topic out of you in the last half hour? What do you think about concepts such as anti-gravity? Is there a way to cancel gravity that through electromagnetism? Is it a matter of that, or is there some other exotic process necessary to block gravitons? To allow things like anti-gravity to exist, or I know gravitons are theoretical as well, but you know what I mean? I don't know.
Yeah, I'm afraid gravitons and tachyons and all those things from Star Trek, they don't really exist.
Right.
Okay.
I do not know any way to cancel out gravity. I don't know a way to reverse gravity. Gravity is one of the 5 forces in the universe.
Mm-hmm.
I say 5 forces. We used to have 4, which is the strong and weak molecular forces, gravity, and electromagnetism. But increasingly, the physics community has been more open-minded to the 5th force in the universe, which Sir Roger Penrose and I wrote back and forth a couple times on, and that's consciousness.
Okay.
He once stated that consciousness was the result of quantum gravity. And I wrote back and said, I think you got it backwards. I think quantum gravity is the result of consciousness.
Huh.
So we're splitting hairs here, but when it comes to what is the first force in the universe,
Mm-hmm.
it's becoming more and more accepted that consciousness was the first force in the universe. It's the primary force in the universe. So to say, is there such a thing as anti-gravity? Not that I know. In fact, thought experiments that I run, I just don't know a way to do it. But I do know that if there is a way to focus gravity and aim it like a jet engine, we could use gravity for propulsion, which means you could use it to lift off of a planet. I don't know that that's been done. There's no demonstration of this anywhere in the universe. All we really see are demonstrations of exactly the opposite. Mass attracts mass. But long before mass gets involved, electromagnetism is involved. Electromagnetism can keep bodies entrained, locked in an orbit of sorts, galaxies around galaxies, clusters of galaxies around clusters of galaxies over billions of light years, which is impossible for gravity. And it's the reason why we invented dark matter and dark energy. We just said, look, the way things are moving in the universe, there's got to be more mass than what we can see. So we just created dark energy to make the math work out. But we don't really know for sure. It could be super bright energy for all that matter. It could be just beyond, our realm to detect it. But I think more than likely, there's no such thing as dark energy or dark matter. I think what we're dealing with is electromagnetism. Wow. It's more of an electric universe than it is a gravitational universe.
Wow.
So go ahead. I'm sorry.
The only evidence I have to back that up right now is what we call backlighting, or that's the best way to describe it. We use bright objects out in the universe like pulsars and quasars and incredibly bright stars. We use them as a backlight to look at the emptiness of space.
Right.
And what we see, of course, the vast majority of space is filled with gas. It's filled with all kinds of gas particles, metals and non-metals and rare earth gases just out there. But the interesting thing about these gases is they align themselves along what appears to be flux lines in space, like fabric, like threads in space. They're not just, filling up a balloon and randomly bouncing off the walls of the balloon. They're, even in the emptiness of space, they are organized. They are lined up, which means or it indicates to us that there are lines of force in the universe, and we believe those lines of force are electromagnetism.
Wow. That's crazy. I mean, in a good way. I'm not at all being mocking. I think that's nothing short of profound. But no, I had heard a physicist once postulate that gravity, her theory was that gravity originated in another dimension, and that's why it's not such a strong force here. Is there any possibility to that?
Well, you're cheating now. You're using the word possibility on me.
Well, I don't know.
I have a weakness for it. But I'm going to say no. That's going to be my answer.
Okay. Well, and I agree. It seemed like a pretty fantastic idea to me, because at that point, if gravity can come through dimensional barriers, then are there really dimensional barriers? I don't know. I don't know.
Well, no, there are things coming into our dimension from other dimensions. We can measure that. If you go to the Laser Interferometer Gravitational Wave Observatories, I know it's a long title.
Wow.
Just put the letters LIGO. I say LIGO. They say LIGO. Okay, so it's LIGO.
I say we have a shot.
There are two of them in the United States. One's in Hanford, Washington, up near you guys. You can go visit it.
Yep.
It's not far away.
Okay.
And then the other one's in Livingston, Louisiana. They're both pretty close to the same age. They were designed by Dr. Kip Thorne and Stephen Hawking.
Huh?
Oh.
They've been in operation for a couple of decades. And the last time I went to the one in Louisiana, they were upgrading the fiber optics and the switchers between the servers. They had the fastest computers on the planet that I know of. They're faster than the ones on Wall Street, that's for sure. And they also have the best laser control. That is to say, they can hold the wavelength of the light of the laser to very, very tight tolerances. No drifting of the wavelength. What these units are like giant laser framing squares. That's the best way I can describe them. It's a laser that's split in two, run down two legs of a right angle, and bounced off of a sapphire-coated mirror 4 kilometers away in a vacuum tube. 4 kilometers now. That means that those mirrors are many, many yards off the ground at the end of that tube, because the laser goes straight and the Earth curves. If there are any flat earthers listening. But that laser light bounces back and forth a lot of times between those two surfaces to form a single laser light about 20,000 miles long.
Wow.
Oh,
and
my God.
Then they tune one of the legs 90 degrees out of phase with the other one, and they cancel them out. So they interfere with each other. That's why it's called an interferometer.
Oh.
And then they wait. And what they're waiting for is a ripple in space-time. Because the theory is that the light will travel in a straight line through space. But if space curves, the laser will curve with it. And when it does, it'll change in length, which will create a signal, a vibration at the sensor. So these instruments are now able to sense all the way down to the Planck length, 10 to the minus 33rd centimeters. That's incredibly sensitive. And what they're witnessing, according to Dr. Fred Robb, that runs the one there in Hanford, I don't know if he's still there, but if you guys go there, you should go there. It's only a couple of hours away. What they're witnessing are particles, photons, popping into our dimension from another dimension. And that's a quote.
Wow.
So we do have information coming into our dimension from another dimension.
Wow.
Wow. So it really really seems to prove the whole multiverse theory then? Would that be correct?
Oh, absolutely.
Yeah.
Absolutely. We figure that there's a limit on dimensions, probably, if you really want to think about it technically, about 26 dimensions.
Wow, okay.
But there's no limit on the number of universes.
Right.
Wow. Okay. So universes go on and on and on and on. There's no end count of them, but in these multitude of universes, infinity, there are 26 possible dimensions of existence.
Yes.
Okay.
And some of those are academic, because we're talking about spins, we're talking about things that mathematically they are a dimension, but in reality there's no place for energy or particles to exist in that dimension.
Oh.
So, and that's our definition of space. Space is void with energy and particles.
Okay.
And there's no place in the standard model for energy or particles to exist in many of those dimensions, but we can't just not say that those dimensions don't exist.
Huh. Now, I don't even know what to say to that, because
I know,
it's like as our awareness grows, do those dimensions then become potential? I mean, is it a matter of
transitional? Like we deal with 3 dimensions pretty well. 1 dimension is a dot, 2 dimensions is a line or a flat plane, but it's basically a flat universe.
Right.
The periodic chart looks different. The molecules in it look different. But in the 3rd dimension, we start with the tetrahedron, which is the first primary shape in the 3rd dimension, and we get more complex from there.
Wow.
I've never thought of a primary shape before. That's kind of an interesting thought.
It's all interesting.
Well, it is the basis of our universe.
Yeah,
I mean, trigonometry means, triangleometry. It's all based on triangles. It's all based on tetrahedrons. All of the energy fields that we create, magnetic fields, all of our electrical science is all based on rotating tetrahedrons.
Mm-hmm.
Wow.
When you talk about 60 cycles, we look at it as a 20,000-mile sine wave, but it's actually a circle. It's a circle. We're starting at the left-hand side at, let's say 9 o'clock. You're going positive up to 12 o'clock, right?
Uh-huh.
Then you're going negative down to 3 o'clock, then negative to 6 o'clock, and then positive up to 9 o'clock again. That's the sine wave. That's
oh my God,
that's
that's
the propagation.
so funny. That is so awesome. Because that just ironclad another idea I had. Wow. Wow.
Well, that's why trigonometry and all the square root functions work so well in electricity.
Right.
When you put a voltmeter on your wall socket, which you could do right now while we're live, don't touch the metal leads. What voltage is it going to read?
It's going to read 12.
It's going to read 120 volts,
120,
right?
Right, yeah.
But that's because the meter is reading root mean squared. It's not reading peak to peak.
Oh, yeah.
If it was reading peak to peak, it would be 169 volts. But we don't use the last little bit, the last 30%. We use 0.707. That's called root mean squared. That's the power that's in the sine wave. The top of it and the very bottom of it, the very tips of the top and bottom, negative and positive, they don't have any additional power because they're kind of going sideways. They're not going up and down.
Right.
They're going over the hill.
Uh-huh.
So we don't use that power. That's why everything is based on root mean squared. The voltmeter you put on the wall is a root mean squared meter. It doesn't measure peak to peak.
Right.
But if I were to full wave rectify that wave and measure the DC, it would be 169 volts.
Wow.
No kidding.
Yeah.
I'm just a drooling mess again.
Okay, yeah, here we go. We just got the beans baked again.
Yeah. Well,
I was cluing in. I was understanding, Hollow Earth, the gravity thought about, on walking on the inside of the mantle, that kind of thing. I was digging that. Now I'm lost again.
You got all that, and where did I lose you? I lost you.
Well-
What, electromagnetism?
I don't think it's any
could
one
go with-
subject. It's just the volume.
Yeah,
It's-
that might be it.
It's the volume of revelations that you've brought and that you bring, and that's why it's such a pleasure to have you on the show. Because I mean, I was very serious when I said, I just want to ask you this and that and this and that, because it's like, I don't know, it's kind of like having Santa show up in the toy room, and you just want to get all the toys from him you can before he has to go. And this is a rare and wonderful opportunity to talk to someone of your knowledge and learning. And we just have a couple minutes left of the show, but I'm going to get to this call we got coming in. Let me get to this.
Okay.
Area code 210. You're on the air.
That's Mac. Mac, answer the phone.
Thank you.
Sorry, were you on hold for long?
I was on hold for long, just in case.
Okay. We only got about 4 minutes left of the show, but go ahead with your question.
I just want to, compliment Mr. Brooks and yourself and the whole TFR community on y'all's success. And I don't really have much of a question.
Okay.
You guys have your perspectives. I have mine. I think the Earth is compressed by all of our thought waves and the light being refracted from our brains and being refracted and then projected and compressing the planet. I'm not really sure what the topic of discussion of tonight was.
Oh, it's just kind of it's kind of just the science of the paranormal. It's just a lot of ideas and scientific theories and understanding to try to illuminate some of these weird phenomena that we've been hearing about.
Well, I always called that prayer myself.
Collective effort. I think it's like a collective effort of everyone projecting what they think the Earth is supposed to be. And the thought waves, or the refraction of light and idea, project it, like literally.
Sure. Well, that's.
Yes.
I always call that prayer, being able to send out light that way from the brain. By the way, I want to get one thing in before we go.
Uh-huh.
The 6th through the 8th, I'm going to be speaking in Sedona, Arizona.
Oh,
so those of you that know X Squared Radio, I'm going to have a PayPal button up there in a few days, maybe this weekend. There are only 200 seats. These are going to sell out in about a week. So if you want to hear this lecture on remembering the future in Sedona, Arizona, there will be a button there for you to click.
Excellent.
Absolutely. Well, thanks for calling in, Mac. I appreciate it. And we'll be talking to you soon, sir. Thanks for calling.
All right, man. You guys have a good night.
All right, you too.
Thanks,
Thank you.
Matt.
Thank you.
And so, Brooks, in closing, we got a couple minutes left, 3 minutes, just about under 3 minutes. How can people keep in touch with what you're doing?
The easiest way is to go to X Squared Radio. I'm a TFR host on the air from 8 to 11 on Sunday nights live. But it's an easy website. I keep it short and concise. It's mobile friendly. That's where you can keep up with everything that I'm doing.
Well, that's fantastic. And I can't thank you enough for being here and sharing all of your knowledge and insights with us and thoroughly schooling us on the nature of our reality that we live in. It's so funny that, it's like swimming in the ocean but never realizing there's the myriad of currents and other factors that are at work. So it's always like going to school when you're on, but it's an amazing experience. You're like the teacher I love to listen to.
Yeah.
I would love for you to come back.
You guys ask the best questions. That's why it's interesting.
Well, I don't know about the best. I know you've been on quite a few shows as a guest, and of course you have your own show that's just mind-boggling. I don't know. Maybe we just asked the more paranormal part of the question. I don't know.
Hey, all paranormal means is above normal.
Above normal. There you go.
There it is. Absolutely. And ladies and gentlemen, thank you so much for being here and being a part of the show. And please stay stay connected with us, you can follow us on Facebook, facebook.com/Paranormal Portal Radio. Make sure you like and subscribe on our YouTube channel, youtube.com/Paranormal Portal. And we are going to be back on Wednesday, of course, with our normal Wednesday stream with just Don and I. And we hope to see you guys there. But that's a YouTube-only stream, so there is no call-in option at that time. But we are absolutely thrilled with this whole month's schedule.
Wow.
And it just keeps getting better and better. I just can't thank you guys enough for everything you've done to promote the show and to spread the word and
show your love.
Show your love. But stick around, ladies and gentlemen, because Jimmy Jean Into the Microcosm will be coming up next here on TFR. And we'll be back on Wednesday. Love you all. Be good, be kind, be nice to each other. Take care, and we'll see you next time on the Paranormal Portal.
Thank you, guys.
Night, Brooks.
Good night, Brooks. Thanks so much.
Night.
Woo!